3D microemulsion pushes the limits of subsurface distribution by promoting advanced micellar transport, which goes far beyond the physical distribution of the material upon injection. Greater distribution translates to cost savings in the form of fewer injection points and less time in the field. In contrast, the use of emulsified oil can be more costly, as it does not move far beyond the point of injection, requiring more closely spaced injection points and more time in the field. To learn more about how 3D microemulsion enhances subsurface distribution, please take a few moments to view a demonstration of the micellar distribution process, the technology that makes 3D microemulsion the intelligent choice in high-volume, wide-area electron donor products. 3D microemulsion is applied to the subsurface. The material is simply pressure pumped into the contaminated saturated zone. 3D microemulsion moves out into the aquifer until it sorbs onto the aquifer medium. Unlike insoluble vegetable oil type products, 3D microemulsion begins to dissolve. Once the dissolved concentration exceeds what is known as the critical micelle concentration, the microemulsion spontaneously forms micelles in groundwater. Micelles are tiny spheres of 3D microemulsion suspended in groundwater, with the hydrophilic end of the molecules facing out to the aqueous medium. These structures often encapsulate volumes of suspended 3D microemulsion material and transport it down gradient. The micelles continue to move outward, further distributing the material beyond the radius of initial injection. The micelles in turn sorb onto the untreated aquifer matrix and redissolve. In this continuing pattern of micellar movement, sorption, and dissolution, 3D microemulsion literally self-distributes once in the subsurface, moving from areas of high concentration surrounding the injection point to untreated areas down gradient. This process eventually coats the entire surface area of the soil particles. The net result is wide area distribution and more cost-effective treatment. Because our process provides for an immediate as well as time-release supply of hydrogen to fuel the demands of the anaerobic reductive dechlorination process, typical longevity for 3D microemulsion is up to 2 years or more on a single injection, and up to 5 years or more under optimal conditions. 3D microemulsion from regenesis equals consistent, long-term hydrogen production, enhanced subsurface distribution, and low cost. The most powerful hydrogen-releasing technology available today.